Many before math. Mathematics decolonized. By the child's own two-dimensional bundle numbers. Make math easy, with many math, where existence precedes essence. Alan Tarp, matecademy.net, Spring 2024. On a 10 by 10 bundle board we see, that a total of 6 sevens, is 6 times 7. Which is bundle less 4, times bundle less 3. Now, slowly, we pull away, the 4 bundles from the top, and then, the 3 bundles from the side. Finally, we add the 4 threes, that were pulled away twice. So, the total is, 3 bundle 12, or 4 bundle 2, or 42. My first math lesson. Hello, my name is Alan. In my first lesson I said, welcome children, I am your teacher in mathematics, which is about the numbers that you can see on this number line, and that is built upon the fact, that 1 plus 1 is 2, as you can see here. So. Then a child stopped me, holding 4 fingers together 2 by 2, Mr. Teacher, here is 1, and here is 1. You say it is 2, but we can all see, that it is 4. The child separated the fingers, and then held 3 fingers together on both hands before separating them. And, here we see that 2 times 3 gives 6. So, multiplication can be trusted, but not addition. Therefore, please take away your number line addition, with its flat earth math. Instead, please help us with the numbers we bring to school, multiplication bundle numbers, as 2 3s and 4 5s, that we can see on this 10 by 10 pegboard, a bundle board, or a BB board. And that we would like to add next to as 8s, or on top as 3s, or as 5s. If we add them next to, we add areas, which my uncle calls integral calculus, and if we add them on top, the units must be changed to the same unit, which my uncle calls proportionality. He says it is taught the first year at college, but we need it here, to keep and develop the bundle numbers with units, we bring to school, instead of having them colonized by your line numbers, without units. We know that you prefer to bundle in tens, and in 10 tens, and in 10 10 tens, but we like to bundle also in 2s, in 3s, in 4s, in half tens, etc. And we know that you have not been taught this, and that the textbook doesn't teach it, but don't worry, we will teach you. Or better, instead of you colonizing our ways, let us find out together what math may grow from our bundle numbers with units. My uncle is a philosopher, and he calls it existentialism, when you treat existence before essence. So, let us begin with the fingers on a hand. You only see the essence, 5, but we see all the ways the fingers may exist as 5. That is, as 5 ones, as 1 5s or 1 bundle 0, 5s, as 1 bundle 1, 4s, as 1 bundle 2, 3s, or 2 bundle less 1, 3s, as 1 bundle 3, or 2 bundle 1, or 3 bundle less 1, 2s, or as 1 bundle, 0 bundle, 1, 2s. What happened next is seen in this workshop, and this folder. The workshop is a video called, Flexible Bundle Numbers, Develop the Child's Innate Mastery of Many, a Paradigm Shift, from line numbers without, to bundle numbers with, units. Meeting many, we bundle count, before we add. The folder is called, Decolonize Mathematics, with the child's own two-dimensional bundle numbers with units. Mathematics is easy, if many is mastered first, with many math. The links are seen below. But, the goal of math education, is it well defined? What comes first, to master math, or to master many? All say, the goal is to master math, to later master many. But math is hard. Why not first master many, to later master math? So we may ask. What mathematics may grow from children's innate mastery of many, as developed before school? What to master first, many, or mathematics? Many, because then mathematics becomes just so easy. Many-matics respects, that many is described by the child's own bundle numbers, with units, instead of having a false identity imposed, with line numbers without units, that becomes mathematism, by claiming, that 2 plus 1, is 3, always, despite the fact that 2 days, plus 1 week, is 9 days. Many mathematics is discovered by asking a 3-year-old, how many years next time? Typically, the answer is 4, with 4 fingers shown. But held together 2 by 2, the child says no, that is not 4, that is 2 twos. The child thus sees, what exists in space, and in time, bundles of 2s in space, and 2 of them in time, when counted. So, what exists are totals, that can be counted and united in time and space, such as a total, t, of 2 twos. Many mathematics are based on a philosophy called existentialism, which holds, that existence precedes essence. In other words, what exists, outside precedes what is said about it, inside. Aha, with existence before essence, counting comes before adding. No, that is not 4, that is 2 twos. This statement will change mathematics education forever, since, as educated, essence is all we see. But as uneducated, the child sees what exists, bundles of 2s in space, and 2 of them when counted in time. The number 2 thus exists both in space, and in time. In space, 2 exists as 2s, a space number, a bundle of 2s, a 2 bundle, which can be united with a 3 bundle. Either horizontally to a 2 plus 3 bundle, a 5 bundle, or vertically to a stack of 2 bundle 1, 2s, or to 2 bundle less 1, 3s, with b for bundle. Here 1 plus 1 does not add up to 2, since the units are not the same, whereas 1 2 bundle plus 1 2 bundle may both be 2 2 bundles, or 1 4 bundle, but not 2 4 bundles. In time, 2 exists together with the unit that was counted, as 2 units, as a time number, or a counting number. So, 2 plus 3 is 5 only with like units. Without units, a counting number is an operator, to be multiplied with a unit, to become a total, that can be added with another total, if the units are the same, or after the units are made the same, by recounting the 2 totals in the same unit. So, as space numbers, 2 plus 3 is 5, whereas as time numbers, 2 plus 3 is undecided, until their units are known. The child thus opens our eyes for a different mathematics that, freed from its present essence bounds, may return to its original identity, as a natural science about many, in space and in time. This decolonization allows us to develop a natural number language, to communicate about outside existence, instead of about inside essence only. If existence comes before essence, then counting comes before adding, which is new, since normally we just get numbers to add. Kids use units, 2 3s, schools don't. So math differs, inside and outside, the no-unit math greenhouse. Inside the no-unit math greenhouse, 2 plus 1 is 3, always. This is mathematism, true inside, but seldom outside. Outside, we use, many math. Asking 2 plus 1 is what, the answer depends on the units. 2 weeks plus 1 day, is 15 days. 2 meter plus 1 meter, is 3 meter. 2 kilometer plus 1 millimeter, is 2 kilometer. $20 plus 10%, is $22. 2 plus 3 is 5 sometimes, but 2 times 3 is 6 always. Why? Because here, 3 is the unit. Many math uses bundle numbers with units. With units, there are only 4 kinds of numbers in the world. Unit numbers and pure numbers, that can be unlike or like, and that may be reunited. The aim of mathematics is therefore not to math, because math is not an action word, but to act. Reunite unlike and like unit numbers and pure numbers. $3 and $2 are unlike unit numbers, where the calculation 3 plus 2 equals 5 predicts the result of uniting them. 3 times $2 are like unit numbers, where the calculation 3 times 2 gives 6, predicts the result of uniting them. 3 times 2% are like pure numbers, where the calculation 102% raised to the power 3 gives 106.12%, predicts the result of uniting them to 6%, as well as 0.12% extra in compound interest. Unlike pure numbers we meet in mixtures, such as 2 kilo at $3 per kilo, plus 4 kilo at $5 per kilo. Here, the unit numbers 2 and 4 unite directly, while the per numbers 3 and 5 must first be multiplied to unit numbers before uniting as areas, called integration, where multiplication precedes plus, t equals, 2 plus 4, kilo at, 2 times 3 plus 4 times 5, dollar, or 6 kilo at 26/6, dollar per kilogram. The algebra's square shows the 4 types of numbers in the world, unlike and like, unit and per numbers. The Arabic word algebra means to reunite, that is, to unite and split. Numbers are united in 4 ways. Addition unites unlike unit numbers. Multiplication unites, like unit numbers. Integration unites, unlike per numbers. And power unites, like per number, as you add 5% by multiplying by 105%. The opposite is to split into, subtraction splits into, unlike unit numbers, division splits into, like unit numbers, differentiation splits into, unlike per numbers, and the factor finding root and factor counting logarithm splits into, like per numbers. Digits are icons. Children love making number icons of cars, dolls, spoons, sticks. Changing 4 ones to 1 fours creates a 4 icon with 4 sticks. An icon contains as many sticks as it represents, if written less sloppy. Once created, icons become units when counting in bundles, as kids do. Totals are counted in bundles, with units. 5 fingers are counted as 1 bundle 2 threes, or short as 1b2 threes, or simply 1, 2, threes. And 10 fingers are counted as 3 bundle 1 threes, or as 1 bundle bundle, 0 bundle, 1 threes, or as 1 bb, 0b, 1, threes, or simply 101, threes. A total, t, is counted in a unit, for example, t equals 3 fours, or t equals 3 times 4. This is called a number narrative, with a subject, t, a verb, equal to, and a predicate, 3 times 4. In the total, t equals 345, we have omitted the units, t equals 3 bundle bundle, 4 bundle, 5, where the bundle, b, is 10. Counting 5 in twos can be done in 3 ways, normal, or with overload, or with underload. 5, is 2 bundle 1, or, 1 bundle 3, or, 3 bundle less 1, twos. Likewise, t equals 47, equals 4 bundle 7, equals 3 bundle 17, equals 5 bundle less 3, tens. This eases calculations. 45 plus 27 is, 4 bundle 5, plus 2 bundle 7, which is 6 bundle 12, which is 7 bundle 2, which is 72, and 7 times 56 is, 7 times 5 bundle 6, which is 35 bundle 42, which is 39 bundle 2, which is 392. 392 divided by 7 is, 39 bundle 2, divided by 7, which is 35 bundle 42, divided by 7, which is 5 bundle 6, which is 56. So, place values, and carrying, and borrowing, are unneeded. Bundle bundles are squares. On a BB board we see, that all the bundle bundles are squares, 2 twos, 3 threes, 4 fours, 5 fives, etc. 2 twos need 2 more twos, and 1 corner, to be 3 threes. So, 1 bundle bundle, threes, is 1 bundle bundle, 2 bundle, 1, twos, or 2 plus 2, bundle, 1, twos, or 4 bundle, 1, twos, or 0 bundle 9, tens. 4 fours need 2 more fours, and 1 corner, to become 5 fives. So, 1 bundle bundle, fives, is 1 bundle bundle, 2 bundle, 1, fours, or 5 plus 1, bundle, 1, fours, or 6 bundle, 1, fours, or 2 bundle, 5, tens. Going the other way, we see that 1 bundle bundle, fours, comes, if we from 1 bundle bundle, fives, pull away 2 bundles, and add the corner, that we pull away twice, which shows that minus times minus must be plus. 1 bundle bundle, fours, equals 1 bundle bundle, less 2 bundle, 1, 5s, equals, 5 minus 2, bundle, 1, 5s, equals 3 bundle, 1, 5s, equals 1 bundle, 6, 10s. 1 bundle bundle, 2s, equals 1 bundle bundle, less 2 bundle, 1, 3s, equals, 3 minus 2, bundle, 1, 3s, equals 1 bundle, 1, 3s, equals 0 bundle, 4, 10s.
Divide and multiply and subtract and add, may be demodeled as icons, also. From 9, push away 4s, we write 9 over 4, iconizing a broom, called division. 2 times lift the 4s to a stack, we write 2 cross 4, iconizing a lift, called multiplication. From 9, pull away 2 4s to find unbundled, we write 9, pull away 2 times 4, iconizing a rope, called subtraction. Uniting next to, or on top, we write B plus C, iconizing the 2 directions, called addition. Shifting units creates a recount formula. To recount 8 in 2s, division predicts the result, 8 over 2 is 4. So 8 is 4 2s, or 8 is 8, over 2, times 2. So, T is T, over B, times B. This recount formula occurs all over STEM, and it also solves equations. Calculations predict counting results. Here, we bundle count a total of 9, in 2s. 9, bundled in 2s, leaves 1 unbundled. We stack the 4 bundles as, 4 times 2. With 1 unbundled placed on top. From 9, 9 over 2 times, we push away 2s. From 9, we pull away 4 2s, leaving 1. So, the calculator prediction is T equals 9 equals 4 bundle 1, 2s. The unbundled is placed on top. Separated by a decimal point, 4.1, 2s, or counted in bundles as 1 equals 1 over 2, times 2, giving 4.5 bundles, 2s, or counting what is missing in a full bundle, 5 bundles less 1, 2s. So, inside decimals, fractions, and negatives, are rooted in, how we outside see the unbundled.
Splitting. The reverse of uniting is splitting, which is predicted by reverse calculations called equations, where we use the letter u for the unknown number. In the reverse calculation, equation, u plus 2 is 5, we ask what is it that united with 2 gives 5. The answer, of course, is obtained by the reverse process, by now pulling away the 2 from 5 by minus, so u is 5 minus 2. The unknown number is thus found by moving the known number to the opposite side, with the opposite calculation sign, the opposite side and sign method. In the equation u times 2 is 6, we ask how many 2's are in 6. The answer, of course, is obtained by counting 6 in 2's, 6 equals, 6 over 2, times 2, so u is 6 over 2. So again, by the reverse process, by pushing away 2's. So, again opposite side and sign. In the equation 2 to the power u is 8, we ask how many factors 2 are there in 8. The answer is obtained by the factor counting logarithm, u is log 2 of 8. So, again opposite side and sign. Equations are solved by moving the numbers to opposite side with opposite calculation sign. In the equation u to the power 3 is 8, we ask, which factor are there 3 of in 8? The answer is obtained by the factor finding root, u is the third root of 8. So, again opposite side and sign. In the equation 2 times 3 plus u times 5 is 4 times 8, we ask 2 3's plus how many 5's give 4 8's. The answer is obtained again by the reverse process, by pulling away the 2 3's, and then counting the rest in 5's, also called differentiating, where minus precedes division, as the opposite of integrating. A hymn to equations. Equations are the best we know. They're solved by isolation. But first, the brackets must be placed around multiplication. We change the sign, and take away. So only u itself will stay. We just keep on moving, we never give up. So feed us equations, we don't want to stop. The equation is 3 times u plus 2 equals 14. First, the brackets must be placed around multiplication, 3 times u plus 2 equals 14. Then we change the sign, and take First 2, then 3, away, so only u itself will stay. So the unknown u now may be found as 14 minus 2, divided by 3, which is 4. Walking the equation 3 times u plus 2 equals 14, in time. First we multiply u by 3, then we add 2, and get 14. So, going back, first we subtract 2, the we divide by 3, and get the result 4, that we then check by saying, 4 times 3 gives 12, that added with 2, gives 14. Recount between icons and tens. The question how many 8s in 32 is predicted by the equation, u times 8 is 32, with the solution, u is 32 over 8, since 32 recounted in 8s gives, 32 is, 32 over 8, times 8. The question how many 10s in 6 7s is predicted by placing them as a stack on a bundle board, a BB board, to learn early algebra. 6 times 7 equals, b lay 4, times, b less 3, which is equals 10b minus 4b minus 3b plus 4 times 3, as the 4 3's are pulled away twice. Increasing the base, will decrease the height. A total may be stacked, tenned, or squared. Here, 4 5s is recounted as 2 10s, with double base, and half height. Next, 4 5s is recounted into a square, where the side is called the square root. The surplus, 4 1s, is shared by the 2 4 time t, stacks. This gives, 8 times t, equals 4, or t equals 4 over 8, equals 0.5. So, the square root of 20 is close to 4.5. The calculator says that the square root of 20 is, 4.472. Recounting gives per numbers, and fractions. A quantity of goods can be counted in kilograms and dollars, connected by a per number, as 4 kilo per $5, or 4 kilo over $5. We then change the unit by recounting in the per number. This is also known as proportionality. Question, 20 kilo equals how many dollar? Answer, 20 kilo equals, 20 over 4, times 4 kilo equals, 20 over 4, times $5 equals $25. Nature and STEM are filled with per numbers. Motion can be counted in meters and seconds, where the per number, meter per second, is called the speed. Water can be counted in grams and liters, with the per number gram per liter. With like units, per numbers become fractions. $4 per $5 is 4 per 5, and $40 per $100 is 40%. Question, with $40 as 100%, $8 is how many percent? Answer, $8 is, 8 over 40, times $40, that is 8 over 40, times 100%, that is 20%. Question, with $40 as 100%, 80% is how many dollar? Answer, 80% is, 80 over 100, times 100%, that is 80 over 100, times $40, that is equals $32. The recount formula is the core of STEM. STEM typically contains multiplication formulas about changing units. Kilogram equals, kilogram per cubic meter, times cubic meter equals density times cubic meter. Force equals, force per square meter, times square meter equals pressure times square meter. Meter equals, meter per second, times second equals speed times second. Energy equals, energy per second, times second equals watt times second. Energy equals, energy per kilogram, times kilogram equals heat times kilogram. Gram equals, gram per mole, times mole equals molar mass times mole. Change in momentum equals, change in momentum per second, times second equals force times second. Change in energy equals, change in energy per meter, times meter equals force times meter equals work. Energy per second equals, energy per charge, times, charge per second, or watt equals volt times ampere. Recounting sides in a stack, half by its diagonal, gives trigonometry, before geometry, and pi. In Greek, geometry means to earth measure. The earth may be divided in triangles, that may be divided in right triangles, that may be seen as a stack, half by its diagonal. This half stack has three sides, the base, B, the height, H, and the diagonal, D, connected with the angle, A, by per number formulas, recounting the sides pairwise. H, equals, H over B, times B, equals tangent A, times B. H, equals, H over D, times D, equals sine A, times D. B, equals, B over D, times D, equals cosine A, times D. H times H, plus B times B, equals D times D, so the sides add as bundle bundles. Tangent A, equals H over B equals dy over dx equals rise over run, equals the diagonal gradient. A circle contains very many small half stacks, so half the circumference, called pi, is n, times tangent of 180 over n, for n large.
Once counted and recounted, totals may be added, but next to, or on top. Adding 4 5s and 2 3s next to as 8s, means adding areas, as in integral calculus. Adding them on top as 5s, means changing units, by recounting. Reversing next to addition. If T1 as 2 3s, together with T2 add next to, as 4 7s, then what is T2? We pull away the initial block, T1, before recounting the rest in 4s. The recount formula predicts the result. So, we pull away the 2 3s from the 4 7s, before recounting in 4s. Since reversed next to addition finds area differences, it is called differential calculus. Here subtraction precedes division, which is natural as reversed integration. Pair numbers add as areas, called integral calculus. We ask, 2 kilograms at $3 per kilogram, plus 4 kilograms at $5 per kilogram, is 6 kilograms at how many dollar per kilogram? We see, that unit numbers add directly. But, that pair numbers must be multiplied to unit numbers, to be added. And, since multiplication creates areas, pair numbers add as areas, under the pair number curve. So, in integration, multiplication comes before addition. Therefore, pair numbers and fractions are not numbers, but operators, needing numbers to become numbers. Here, the pair number curve is piecewise constant. It becomes locally constant by interchanging epsilon and delta. Then the sums are replaced, by integrals. Subtracting pair numbers is called differentiation. Reversing adding pair numbers, we ask. 2 kilograms at $3 per kilogram, plus 4 kilograms at what, gives, 6 kilograms at $5 per kilogram. We first pull away the initial 2 by 3 block, before we recount the rest, in 4s, to get the pair number. So, reversed pair number addition means subtracting areas, to be reshaped, called differential calculus. Here subtraction, giving a change, delta, comes before division, the reverse of multiplication before addition, in integral calculus.
Adding bundle squares. On a BB board we place 4 2 by 3 stacks, so they form a 5 by 5 square, that inside contains 2 squares, 2 2s, and 3 3s, as well as 2 stacks. But it also contains 1 square formed by the diagonals in the stacks, as well as 4 half stacks. So, in this stack, adding the height and the bundle as squares gives the square of the diagonal. This rule is named by the ancient Greek thinker, Pythagoras. The 2 squares 4 4s and 3 3s thus add as the square, formed by the mutual bottom top, BT, line, having the length as the square root of the sum. So, square root, 4 squared plus 3 squared, equals 5. Subtracting bundle squares. From a 7 by 7 square, we pull away a 3 by 3 square. This leaves a 7 by 7 minus 3 stack, and a 7 minus 3 by 3 stack, that may be turned to a 3 by 7 minus 3 stack. Totaling a 7 plus 3 by 7 minus 3 stack. So, 7 squared minus 3 squared is 7 minus 3 times 7 plus 3. Adding squares also solve quadratic equations. On a BB board we see that t equals x plus 3 times x plus 3 is a square with 4 parts, 2 squares, x squared, and 3 squared, and 2 stacks, 2 times 3 times x, so that t is x squared, plus 6 times x, plus 9. The quadratic equation, x squared, plus 6 times x, plus 8, is 0 then makes the whole square go away, except for 9 minus 8, that is 1. So, x plus 3, squared is 1, which gives two solutions, x is minus 2, and x is minus 4. The quadratic equation, x squared, plus 6 times x, plus 10, is 0, has no solutions, since here, x plus 3, squared is negative, minus 1.
Subtracting numbers with like units, 9 minus 6. Inside the no-unit math paradigm, numbers subtract serial, or next to, on the number line. We find the result by counting backwards. Outside, in the unit math paradigm, numbers subtract parallel, or on top, showing that t is 9 minus 6, which is 3, or that t is 6 minus 9, which is less 3, since 6 is 9 less 3. Subtracting directly as less numbers, gives the same result. Again we see, that minus minus, is plus.
Adding numbers with like units, 7 plus 9. Inside the no-unit math paradigm, numbers add serial, next to, on the number line. We find the result by counting on, from 7 or 9. Outside, in the unit math paradigm, numbers add parallel, on top. We see that, t equals 7 plus 9, equals 2 bundle 7, 7s, equals 2 bundle less 2, 9s, equals 2 bundles less 4, 10s, equals 1 bundle 6, 10s, equals 16. Added directly as less numbers. T equals 7 plus 9, equals bundle less 3, plus bundle less 1, equals 2 bundle less 4, equals 16. Added directly as half bundles. T equals 7 plus 9, equals half bundle 2, plus half bundle 4, equals 1 bundle 6, equals 16. Decolonizing, by demodeling and deconstruction. Two colonizations, bundle numbers, first by mathematism and line numbers, then by metamodism and sets. Mathematism, and essence, versus, many math, and existence. What is digits? Symbols. No, icons. What is 345? The place value system tells it. No, t equals 3 bundle bundle 4 bundle 5, bundle bundle equals bundle squared, bundle 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 equals bundle cubed. What is operations? Functions, the order is, plus, minus, multiplication, division, and power. No, icons, in the opposite order. What is 3 plus 4? 3 plus 4 equals 7. No, it is meaningless without units. What is 3 times 4? 3 times 4 is 12. No, 3 times 4 is 3 fours. 9 is how many twos? Meaningless, only 10 counting is used. No, 9 equals 3 bundle 3, equals 5 bundle less 2, equals 4 bundle 1, equals 4 1/2, twos. 8 is how many twos? Meaningless, only 10 counting is used. No, 8 is, 8 over 2 times 2 and t is, t over b, times b, called recounting or proportionality. What is u, if 2 times u is 8? 2 multiplied with u, times 1/2, is 8 times 1/2. So, u multiplied with 2, times 1/2, is 4. So, u times 2 multiplied with 1/2, is 4. So, u times 1, is 4. So, u is 4. No, 2 times u is 8, that is 8 over 2, times 2, so u is 8 over 2. 6 times 7 is what? E, 44. E, 52. E, 42, okay. No, 6 times 7 is bundle minus 4, times bundle minus 3, that is 10 minus 4 minus 3, times bundle, plus 12, that is 3 bundle 12, that is 4 bundle 2, tens, or 42. If 4 kilo equals $5, then what is 6 kilo? 1 kilo is, 5 over $4, so, 6 kilo is 5 over 4, times $6. No, 6 kilo is 6 over 4, times 4, kilo, that is 6 over 4, times 5, dollar. What is 1 over 2 plus 2 over 3? 1 over 2 plus 2 over 3, equals 3 over 6 plus 4 over 6, equals 7 over 6. No, 1 over 2, times 2, plus 2 over 3, times 3, is 3 over 5, times 5. What is 2 times 3 plus 4 times 5? 2 times 3 plus 4 times 5, equals 10 times 5, equals 50, 6 plus 20, equals 26. No, 2 times 3 plus 4 times 5, equals 2 3s plus 4 5s, equals 3 bundle 2 8s, by integration. What is 7 plus 9? 7 plus 9 is 16. No, 7 plus 9 is 2 bundle 2, 7s, or, 2 bundle less 2, 9s, or, half bundle 2, plus, half bundle 4, 10s, which is, 1 bundle 6, 10s, or 16. What is tangent? Tangent is sine over cosine. No, the rise is, the rise over the run, times the run. So tangent is the rise, over the run. Totals in time and space, growth and statistics, 1. In time, a total grows by being added, or multiplied by a number, called addition growth, or multiplying growth, or linear or exponential growth. Addition growth, final number equals initial number plus growth number times the growth times, or shortly, t equals b plus a, times n. The number, a, is also called the slope. Multiplying growth, final number equals initial number times the growth factor to the power of the growth time, or shortly, t equals b times a, to the power n, since $200 plus 5% equals, 200 times 105%, dollar, so here, a, is 1 plus interest rate. Combined growth, savings in a bank. Here we have that major A over minor A is the same as major R over minor R, where, major A, is end dollars, and, minor A, is the period dollars, and major R is the end rate, and minor R is the period rate, and 1 plus major R equals, 1 plus minor R, to the power n, where n is the number of periods. 100% split in n parts will give the Euler number, E equals, 1 plus 1 over n, to the power n, for n large. Totals in time and space, growth and statistics, 2. Changing the growth number constantly, will give a quadratic growth, with a parabola curving upwards or downwards, if the change increases or decreases. Changing the curvature constantly, will give cubic growth, with a double parabola with curvature and counter curvature. Decreasing the growth factor constantly, will give logistic saturation growth, with a hill curve, as with infections. Confusion between exponential and saturation growth can cause unnecessary damage. In space, a total can be divided into several subtotals, that could be as large as their average, but where the deviation then tells how far away from the average they are. However, averaging numbers only makes sense, if they could be equal. Students in the 1st and 9th grades do not attend the 5th grade on average. Mathematism uses line numbers without units. Many math with units is based on the concrete existence, many, and uses bundle numbers with units, and distinguishes between unit numbers and pure numbers. Set mathematics without units is based on the abstract essence, set, and does not accept pure numbers, but is based upon line numbers without units that become mathematism, always true inside but rarely outside class, by claiming that 2 plus 1 equals 3, despite 2 pairs plus 1 equals 5. And by claiming that digits and fractions are numbers when instead they are operators needing a number to become a number. That sets lead to a self-reference paradox is neglected. The set of sets that do not belong to themselves, does it belong to itself or not? Well, it does, if it does not. And it does not, if it does. This is equivalent to asking. This sentence is false, is it true or false? Well, it is true, if it is false. And it is false, if it is true. In short, self-reference is meaningless. More sides of school mathematism. Mathematics considers digits and operations as symbols, just like letters. Multi-digit numbers are said to follow a place value system, but 10 is not called bundle, 100 is not called bundle-bundle, which would allow power as the first operation. Negative numbers are not allowed on any place. Reuniting occurs with the same operations, however, they are presented, not simultaneously, but in the opposite order: addition, subtraction, multiplication, division, power. 3 plus 1 equals 4 is presented as different number names for the same total. And not as a tale about a total, t equals 3 plus 1 equals 4. That is, both the subject and the verb are omitted. Only an equivalence between number names is included. Over and under load are not accepted, carrying and borrowing are used instead. 2 plus 3 times 4, is that 20 or 14? This is determined by the definition known as the PEMDAS math hierarchy. Even though t as 2 plus 3 times 4 is 2 ones, plus 3 fours, which can only be recounted as one bundle 4 tens, or 14. More sides of school mathematism. 6 times 7 is presented as another number name for 42, even though 6 times 7 is 6 sevens, which may or may not be recounted to tens as 4 bundle 2 tens, or 4.2 times 10, or 42, if leaving out the unit, and the decimal point, and here, increasing the width from 7 to 10 will decrease the height from 6 to 4.2. 8 divided by 2 here means 8 divided into 2 4 bundles, instead of 8 counted in 4 2 bundles. The tables are memorized: 6 times 7 equals 42. Instead of saying 6 times 7 is b minus 4 times b minus 3, or 6 times 7 is 6 times b minus 3 equals 6b minus 18 equals 6b minus 2b minus 2 equals 4b2 equals 4.2 times 10, with less height. Here we see that minus times minus gives plus. Letter calculations such as 2 times a times b plus 3 times b times c equals 2a plus 3c times b are presented as applying the distributive law, where numbers can be moved in or out of parentheses, and not by finding the common unit, b's. The number of b's is 2 times a plus 3 times c, so t equals 2a plus 3c, b's equals 2a plus 3c times b. More sides of school mathematism. Division leads on to fractions, decimals, and percent. Fractions are presented without units: 1/2 plus 2/3 equals 7/6, even though 1/2 of 2 apples, plus 2/3 of 3 apples, is 3/5 of 5 apples, and, of course, not 7 apples of 6. Proportionality tasks are solved by going over the unit. Negative numbers are introduced as independent numbers, where minus times minus is defined to be plus. Splitting numbers is called solving equations, with two numbers names, whose equivalence is expressed in a statement that retains its truth value, if the same operation is performed on both number names. When transforming a number name, three laws are used: a commutative, an associative, and a distributive law. And two abstract concepts: 1/2 as the inverse element to 2, as well as the neutral element, 1. Instead of simply moving to opposite side, with opposite sign. More sides of school mathematism. Quadratics omit drawing x squared plus 6x plus 8 equals 0 as the square x plus 3, squared with 4 parts, x squared, and 3x, og 3 squared, that disappear, except for 3 squared minus 8, that is 1. If the school presented inner essence as stemming from external existence, then functions could be presented as number language sentences, that connect an outer subject, with an inner predicate, as in the word language. Instead, the school says, a function is a rule, that assigns to each element in one set, one and only one element, in another set. And in teacher training, a function is a subset, of a set product, in which first component identity, implies, second component identity. More sides of school mathematism. Where x represents an unspecified number, f of x represents an unspecified formula, with x as a variable number. The term f of 2 is therefore meaningless, since 2 is not a variable but a constant number. Linear and exponential functions are then defined as examples of homomorphisms. F of x is a times x, and f of x is a to the power x, without an initial number, b. In geometry, plane geometry and coordinate geometry are presented before trigonometry. Calculus is presented last, with differentiation before integration, although mixture calculations mean adding piecewise constant per numbers, which later become locally constant per numbers, that are rewritten as increments, p times dx equals dy, which add as one difference, between end y and start y, as all intermediaries disappear. In addition, mathematism introduces 8 so-called mathematics competences, where many math have only 2, count and add, in time and space, the cat's approach. There are 8 competences in mathematism, only 2 in many math. Count and add in time and space, the cat's approach. With many math, outside. To master many, first we count, then we add. With mathematism inside the no-unit greenhouse. 8 competences are needed, to be applied outside. Fact and fiction and fake, the 3 genres of both the word and the number language. Once we know how to count and recount totals, and how to unite and split the 4 number types, we can now actively use this number language to produce tales about numbering and numbers, and about totaling and totals in space and time. This is called modeling. As in the word language, number language tales also come in 3 genres, fact, fiction, and fake, models, that are also called since then, if then, and what then, models, or room, rate, and risk, models. Fact models talk about the past and present, and they only need to have the units checked. Fiction models talk about the future, and they need to be supplemented with alternative models, built upon alternative assumptions. And fake models typically add without units, example when claiming that 2 plus 3 equals 5 always, despite 2 weeks plus 3 days equals 17 days, thus transforming mathematics into mathematism. The unit math paradigm allows finally, to have a communicative turn, in mathematics education. Modeling real-world problems is difficult for mathematism, that also fails to distinguish between the 3 genres, fact, fiction, and fake, since then, if then, what then, or, room, rate, risk, models. All models are said to be approximations. By using formulas from the start, many math avoids modeling problems, as it sees itself as a number language parallel to the word language, both of which have a meta-language, a grammar, and 3 genres, fact, fiction, and fake. Fake models can be mathematism, adding numbers without units, as well as averages of numbers, that could never be equal. Our language house thus has 2 languages, a word language and a number language. And it has 2 floors. On the lower floor, the language describes the outside world. And, on the upper floor, the meta-language, or grammar, describes the inside word or number sentences.
A final question. In the United Nations 17 Sustainable Development Goals, number 4 is about quality education. Should ethical quality education force children to enter inside a no-unit math greenhouse that slowly strangles their innate number language by using line numbers to learn no-unit addition that folds outside? Where children's innate mastery of many just waits to be developed by flexible bundle numbers available at their fingertips.
Sociology explains mathematism. Sociology sees people as individuals, working towards goals. Both individually, and jointly, through institutions with employees, who should work for the common goal to be achieved, but who are tempted to make a so-called goal displacement, by instead working to ensure that the goal is not achieved, as this will ensure continued employment, and more resources for extra hours, and for more employees. The school's goal is to make children and young people more self-reliant than they already are. This is also true in terms of their mastery of many, as it appears in time and space. To achieve this goal, the school has hired mathematism, which unfortunately has fallen into the temptation to make a goal displacement, so that it has become the goal itself, and which therefore constantly wants more resources, for extra hours, and for more employees to teach, and to research the difficult mathematism. By instead firing mathematism, the school can avoid this goal displacement, and allow mastery of many to precede mastery of mathematics, which is then achieved automatically anyhow. The theoretical background for this presentation is 2 articles. Mastering many, by counting and recounting, before adding on top and next to. Journal of Math Education. And demodeling numbers, operations, and equations, from inside to outside understanding. Ho Chi Minh City University of Education Journal of Science. References to mathecademy.net, material. Math with playing cards. Calculus adds per numbers. Refugee camp math. Trigonometry before geometry. Math modeling, and models. 2 competences, or 8. Some of Mr. Altarp's 25 YouTube videos. Many before math. Mathematics decolonized, by the child's own 2-dimensional bundle numbers. And flexible bundle numbers, develop the child's innate mastery of many. And trigonometry before geometry, probably makes every other boy an excited engineer. And preschoolers learn proportionality and integration by icon counting and next to addition. And deconstructing fractions. And a postmodern mathematics education. And many more. Many math solving a Facebook puzzle. The question was, if 1 plus 4 is 5, and 2 plus 5 is 12, and 3 plus 6 is 21, then what is 8 plus 11? Many different answers were given. Until many math found the answer, by using units. 1 ones, plus 4 ones, equals 5. 2 ones, plus 5 twos, equals 12. 3 ones, plus 6 threes, equals 21. 8 ones, plus 11 fours, equals 52. We began by observing the difference between mathematism, adding numbers without units, which is true inside, but seldom outside, and many math, instead using bundle numbers with units, inspired by how the uneducated child sees the outside existing fact, many. We then explored the consequences of letting existence come before essence, by letting counting and recounting come before adding. We saw how many math may be learned by working with things and actions on a 2-dimensional bundle board. But will this allow the learner to learn mathematics, or even to be numerate, as wished for by the UN Sustainable Development Goals? Apparently, different definitions of numerate exist, where existence and essence have different order. The English Oxford Dictionary defines it as being competent in the basic principles of mathematics, especially arithmetic. In contrast, the American Merriam-Webster Dictionary defines it as having the ability to understand and work with numbers. In their common history, England once colonized America. So, the difference in the definitions is interesting. The former uses the passive term being, where the latter uses the active term having. The former connects the definition to the inside essence of mathematics, while the latter connects it directly to the outside existence of numbers. The choice thus is, shall existence precede essence, as philosophical existentialism holds, or shall essence be allowed to colonize existence, with a no-unit regime, to use a Foucault phrase? Maybe it is time to see if children stay numerate, if their own 2-dimensional bundle numbers with units are not colonized by 1-dimensional line numbers without units. Maybe it is finally time for a Kuhnian paradigm shift in number language education. Therefore, think things. Or, in the Viking version, Dörfer, Tank Ting. Many before math. Mathematics decolonized. By the child's own 2-dimensional bundle numbers. Make math easy, with many math, where existence precedes essence. Alan Tarp, mathecademy.net, Spring 2024. On a 10 by 10 bundle board we see that a total of 6 sevens is 6 times 7. Which is bundle less 4, times bundle less 3. Now, slowly, we pull away the 4 bundles from the top, and then the 3 bundles from the side. Finally, we add the 4 threes that were pulled away twice. So, the total is 3 bundle 12, or 4 bundle 2, or 42.